Hi everyone. In this video, I am going to explain about the concept of non-coherent MTA radar. What do you mean by non-coherent and what do you mean by coherent MTA radar? Till now, so far we have seen coherent MTA radars. There I did not mention the name coherent MTA radar, but when we are using two different oscillator like shallow oscillator and stable local oscillator and coherent oscillator, then I told you the transmitted signal frequency must be incoherent with the received signal frequency so that we can eliminate what is the amount of transmitted signal frequency from the receiving section. Okay, see what I am saying here is coherent MTI radar uses a transmitting signal as a reference towards receiving section or receiving signal. What is the purpose of this one? To eliminate the amount of transmitted signal from the receiving signal. Okay, suppose consider a radar system like a coherent radar system, nothing but MTI radar system. So we are transmitting a signal frequency like FT. This signal is transmitted and touches this target. Okay, so during return what happens, we are getting the information FT plus or minus FD. Okay, now during reception we will be having the resultant signal frequency component as FT plus or minus FD, but we are working with only FD, not with FT. Because MTA radar is especially designed to get the information related to moving target, not for the stationary target. FT consists of no information related to target. Okay, but FD consisting of information completely related to the target. So there is no use of carrying the transmitted signal frequency throughout the receiving section. So what we need to do, we need to eliminate the transmitted signal frequency in the receiver. So for that we are taking the same signal like coherent, that is the meaning of coherent, same signal, same phase towards the reference signal as a reference signal towards the receiving section. Okay, so for that purpose we have used two different MTI radars, MTI radar with power amplifier transmitter, and MTI radar with power oscillator transmitter. So MTI radar with power amplifier transmitter, MTI radar with power oscillator transmitter. In these two cases, we have gone with two different oscillators called uses two oscillators. Those are, what are they? Stable local oscillator and coherent oscillator. The purpose of coherent oscillator is to keep the transmitted signal frequency and received signal frequency in coherent. This is the main motto of this coherent oscillator in the MTI radar. Okay, but such type of coherent oscillators now we no need to use in the non-coherent MTI radar, because the concept involved in the non-coherent oscillator is we are not working for the frequencies, but now we are working for the amplitude variations. Okay, amplitude variations, because if the target is in motion, the range is continuously changing. That means the received signal strength is continuously changing if the target is in motion. For the stationary targets, the amplitude will be constant for any number of cycles we transmit. Okay, so if we get the difference between the successive samples, amplitude variation, wherever the amplitude variation is there, only then that represents the transmitted information. Okay, I will explain here. See here, in this non-coherent MTI, we use amplitude fluctuations amplitude fluctuations rather than frequency variations. So why we are using amplitude fluctuations rather than frequency variations? Because the amplitude of the stationary target is constant for any number of cycles, but amplitude of moving target is changing from cycle to cycle. When we are transmitting first cycle, it is having one amplitude. When we are transmitting second cycle, it will be having different amplitude, because the target is keep on moving. If it is moving away from the radar system, then the amplitude decreases. If it is moving towards the radar system, then amplitude increases. Depending on the movement of the target, the amplitude is varying. So block diagram of this non-coherent MTI radar. So what are the different steps involved in the non-coherent MTI radar is, so as I told you, the transmitting section is having a pulse transmitter, pulse modulated signal. So a modulator is used and power oscillator. The output of this one is given to TR. What do you mean by TR? Transmit and receive. TR stands for transmit. I will write completely. Transmit, receive. Or else you can call it as, it is nothing but a duplexer. It is nothing but a duplexer. What is the purpose of duplexer? Whenever we are using a single antenna for both transmission and reception, then definitely we should go for a duplexer to separate transmitting and receiving signals. Okay, so during transmission, it transmits the signal like ft is the transmitted signal frequency. Now during after reception, the transmitted signal frequency is given to a mixer. That means the received signal frequency is being converted into, that means RF signal is being converted into IF signal. So RF signal we are receiving radio frequency signal, that is mixing with the local oscillator frequency, something like crystal oscillator frequency, that is transmitted through mixer and converted into intermediate frequency. So that intermediate frequency, after passing through this IF amplifier, see what is the purpose of IF amplifier? It is used to amplify a particular frequency component, which is nothing but intermediate frequency component. So that is amplified by passing through this IF amplifier and then given to amplitude detector. See the name amplitude detector. Previously the name was phase detector. Previously we have used phase detector. So I will write here, in coherent MTI radar, we use phase detector. What is the purpose of phase detector? It detects the difference between the phases and gives the moving target. Phase is being changed due to moving target. That means ft plus or minus fd we are having. Let us consider the phase will be ft plus or minus fd from the received section, and the transmitted signal frequency will be having ft. So the difference between these two will be given as the Doppler frequency component fd. Okay, this is the purpose of phase detector, what it has to do. But in non-coherent MTI radar, this is not the case. In non-coherent MTI radar, we use what I told you. We are concentrating on amplitude fluctuations, not on the phase fluctuations, not on the frequency fluctuations. So amplitude of the stationary target is constant for any number of pulses, and the amplitude of the moving target is keep on changing. Okay, so we use amplitude detector rather than phase detector. Okay. That means it calculates the difference between the transmitted signal frequency, transmitted signal amplitude, and as well as received signal amplitude. That means the received signal amplitude every time it is being compared with the previous cycle. Okay, so the purpose of amplitude detector is to calculate the difference between successive outputs for each pulse. For each pulse. So if you take two moving targets, this is the, and these are the small equals due to stationary target. This is target 1 and this is target 2, and this is a stationary target 1, and this is the echo due to stationary target 2. This is for the first cycle. When we are going for the second cycle, if the target is moving away from the radar system, if the targets are moving away from the radar system, okay, this is the echo signal. This is target 1 echo, and this is target 2 echo, and this is stationary target 1, and this is due to stationary target 2. See here, stationary target 1 and stationary target 2, their amplitudes are not changing from pulse to pulse. But what about the T1 and T2? T1 is having more amplitude here, and T2 is also more amplitude. But what about the T1 and T2 in the second cycle? They will be having reduced amplitude, because we are thinking that the target is coming towards the radar system, so that the range becomes closed. Okay, but if you consider the difference between these two, subtractor, then only moving target will be there. Okay, so this is the concept of the non-coherent MTI radar. In non-coherent MTI radar, we are concentrating on amplitude, not on the phase. Thank you.